Hello, in this video I want to introduce the idea of method of difference. Now let me start by looking at an example. What I want to do is to let me start by saying what I hope to do. I hope to add up I hope to add up this sequence that looks like this. 1 over, I have a sequence like this. The first term is 1 over 1 times 2. The second term is 1 over 2 times 3. Third term is 1 over 3 times 4. Next term 1 over 4 times 5, and so on. So this is term number I'll call it R. Term number 1, term number 2, term number 3, term number 4, and so on. So if I keep going, let's say I go until the nth term. If I go until the nth term, then what I want to do is to add this up all the way until the nth term, and to get a formula for that. Okay, so the sum to nth term. So that's what I hope to do in this example. Now, in order to do this, I need to introduce this idea called method of differences. Okay, there are many different types of sequences. This is just one of the examples, and it happens to have a pattern or nature, a property, such that this method of differences can be used. So let's see what this is all about. Okay, so now in order to carry on, I must first find an expression for the nth term. So and to do that, of course, I need to look for a pattern from term to term. Okay, if you look at these numbers 1, 2, 2, 3, 3, 4, 4, 5, so obviously there must be some kind of pattern here. If I look at the 1, the first number in the denominator, it is 1, and then it's 2, and then it's 3, and then it's 4, and so on. So that's simple enough. Okay, that's a simple pattern. And the next one, the next number is 2, 3, 4, 5, and so on. Or we can also say that the next number is always 1 unit more than the first number. So like 3 is more than 2 by 1, 4 is more than 3 by 1, 5 is more than 4 by 1. So if I just look at the first number and try to write down the nth term, if I start from the first number, the first number of the first term is 1. First number of the second term is 2. First number of the third term is 3. First number of the fourth term is 4. So we can guess following this pattern that first number of the nth term is n. Alright, they're all the same. See, 4 and 4, 3 and 4, 3, 2 and 2. So n and n is a reasonable guess. Okay, what about the next number? Okay, the next number is always 1 unit more than the previous one. 3 is more than 2 by 1, and so on. So therefore we can think that this next number must be 1 unit more than n. and that's just n plus 1. Okay, so and just to make sure that this is the correct formula, I can just pick any r, like maybe r equals to 3, and then put 3 into the n here and here, and check that I do actually get the correct term. So once we are sure that this formula is correct for the nth term, okay, just for convenience, I'm going to introduce the a term in r. So let's say for the r term, the formula would just be n replaced by r. So 1 over r plus 1. So I would think of r as something like a counting number. R can be 1, 2, 3, 4, 5, and so on. N would be the maximum number for r. Okay, and the number I want to sum up to. Okay. So I still haven't talked about the method of differences yet. Okay, so I'm getting close. The first thing that I had to do was to get a formula for a general formula like this. So the next thing that I need to do, is to look at this formula. And write it in a slightly in a different way. Now this is not something that is obvious, so I'm just going to write down the expression directly. The expression is this: 1 over r plus 1 is actually equal to, alright, that means this one can actually be written in this form. It's equal to 1 over r minus 1 over r plus 1. We can show by algebra that they're actually equal. Okay, so the next step in this method of differences is to show that each term can be expressed in this form. For this particular sequence, of course, this is going to be different for different sequence. So let's show that, or let's think about why this is true. Okay, we need to make sure that this is true, and the way to do it is to we can just work on either side and show that it's equal to the other side. So it might be easier if we start from the right hand side. So this is what I'll do. I need to prove that this is true. Alright, I need to prove it. Okay, starting from the right hand side. Let me combine the two fractions into a single denominator, r times r plus 1. So just multiply the two, and then for the first for the numerator, I would take 1 times this. For that one would be 1 times r, and then I subtract them. And as you can see, the r and r cancel. I'm left with 1, which is just the same as the left hand side. Okay, so I've just proved that this is indeed correct. Okay, now that we have obtained this, we are ready to apply the method of differences. Okay. The way to see how to carry on is to use this formula for each term in the sequence. Now this expression here is the formula for the r term. right, for one term in the sequence. And what this formula shows is that this equation shows is that this formula for the r term can also be written in this form. Now there's something special about this form which is very helpful. Now to see what is special about it, what we could do is to write out a few of these terms in this form and see what they look like. Okay, so okay, let me make a simple table. Let's say I have r here, and the r term, I'll call it tr. Okay, tr. Right. So when r is 1, I can it's just this one, or I can use this formula. I can use this formula to with r replaced by 1 in order to get the first term. Or I can get the first term by using this formula, because this is the same as the r term formula. If I use this formula, let's see what we get. We get okay, for let me write out the whole write this out as well. So the tr is 1 over 1 times 2, alright, which is just this with r substituted with 1. Now if I substitute 1 into here instead, okay, I'll get 1 over 1 minus 1 over 1 plus 1, which is 2. So 1 minus 1 over 2. Now when r is 2, I should get the second term, which is 1 over 2 times 3. But if I use this, if I substitute r equals to 2 into here and here, I get 1 over 2 minus 1 over 2 plus 1, which is 1 over 3. And when r is 3, the third term is that one, 1 over 3 times 4. But if I use this with r equals to 3 down here, I get 1/3 minus 1 over 3 plus 1. 1/3 minus 1/4. And so on. And if we want to add up all these terms, it's the same as adding up all these. But do you notice something? Notice that if I add up these fractions, I have a minus half here and a half here. I have a minus 1/3 here and a 1/3 here. So these would actually cancel if I add up all this whole lot. And the minus 1/4 here must cancel with a 1/4 in the next term. Now that is something very convenient. See, if they're all going to cancel, then most of them will be gone, except for, say, the very first one and the very last one. Okay, now let me write out the very last one just to check. So the very last one is that one, is the nth term, right? So that's when r equals to n. Then it's 1 over n plus 1, 1 over n plus 1. And using this formula, that would be 1 over n minus 1 over n minus 1. So if you look at this pattern, since this cancel with that, that cancel with that, that cancel with that, and so on. So the one before this must cancel with this. Okay, let's say the one before this will cancel with this. We can write out the n minus 1 just to check if you want, but it seems quite clear that this would happen. So the only terms left are that one and that one. That one here. Okay, mustn't forget the minus sign here. So this means that if I add up this whole lot, it's the same as just that minus this. Okay, so let me quickly write out this conclusion. If I add up this whole lot, if I add this to this to this to this to this all the way until here, my answer must therefore be 1 minus 1 over n plus 1. So that's it. I've got the answer by doing this. It looks like a rather involved. It looks like a rather complicated set of complicated steps, but it ends up with quite a simple solution in the end. Just 1 minus 1 over n plus 1. And we see that all the terms cancel. And this method then is called the method of differences. The method of differences, basically by expressing each term as a difference, and not just any difference. All right, it's a difference in which one you have r in one term and r plus 1 in the next term, in two terms that look exactly the same, except that one contains r and one contains r plus 1, and one has a minus sign, the other one has a positive sign. Right, so if you can express a term, if you can express each term in this form, then it doesn't have to be 1 over r, can be maybe 1 over r squared, or can be something else, as long as the other term which you subtract looks exactly the same, except that the r is replaced by r plus 1. As long as it has this kind of a format, then you'll find that when you start adding all the terms together, most of the terms will cancel, except for the very first and the very last. So this is the idea of method of differences. Of course, it can only work if you can find such an expression, and for most sequences this would not be possible. All right, you can only work for sequences, special examples like this.